This video is for intermediate algebra's topic of variation. So variation is just a special type of word problem. I know word problems, the whole topic is a little scary, but these are the easiest types of word problems. The reason being is that there's only a few types of variation problems, and once you recognize the type of variation, you immediately know what the equation is. You don't have to think about it, you just write the equation. There's going to be keywords to look for, and every variation problem has just 3 parts. The first part is to identify the type of variation. Again, there's just keywords you're going to look for, which are going to tell you what the type is. And then you just use the equation. Next, we want to find the constant, and you'll see that what constant I'm talking about in the next slide. So we want to find this constant of variation and plug it back into our equation. The third part is we want to actually answer the question. After all, this is a word problem. Not all variation problems have all 3 parts. Sometimes you might just be asked to find the constant, or sometimes you might just be asked to find the equation, but usually you'll see all 3 parts. So for the first type of variation we'll explore is called direct variation. Direct variation, you're going to see a problem phrase something like this. Y varies directly as x, or y is directly proportional to x. It doesn't have to be y and x. It could be for something like, for example, maybe weight and height. And in that case, you might use w and h instead. But whatever comes before the varies directly or directly proportional, that's your y. And whatever comes after is going to be your x. So if a problem's worded like either of these, the equation you're going to set up is y equals kx. And again, you don't have to use y and x. You can use other variables. Just remember, whatever comes before the word to indicate that it's direct variation is on the left-hand side is your y variable, and the other one would be on the right. K is just a constant. It's the constant of variation, also called the constant of proportionality. It doesn't really matter. It's just a constant. It's ultimately a number we'll want to find in order to be able to answer the question. So for example 1, let's look at direct variation. We see Jason's weekly income is directly proportional to the time he works. If Jason earns $230 a week when he works 20 hours that week, how much will Jason earn if he works 30 hours per week? So let's break this down into the 3 parts, because as I said, there's 3 parts, and each part of this problem corresponds to a different part that we're going to use to solve the problem. So the first sentence is actually the first part, and that's usually the way it works. So Jason's weekly income is directly proportional to the time he works. We're going to use that to solve the first part. The first half of the second sentence, if Jason earns $230 when he works 20 hours per week, that's going to give us the information to help us set up a specific equation we can use. And then the last part of the sentence, how much will he earn if he works 30 hours per week, that's the actual question we want to solve. So that will help us to work on our third part. So let's break it down. So our solution. So we see that Jason's weekly income is directly proportional to the time he works. Since it says directly proportional, we know that we have a direct variation problem of the form y equals kx. We don't have to use y and x though. In fact, since income starts with an I think I'll use I instead of y. And since time starts with a t, I think I'll use t instead of x. So our equation is going to be, instead of y equals kx, I'll use I equals kt. But if that makes you uncomfortable, just use y and x. That's fine as well. So next, we have our equation to work with. Let's go to part 2. It says if Jason earns $230 when he works 20 hours per week. So the $230, that's our income, and the 20 hours per week is our time. So let's plug those in for I and t respectively. And we get that 230 equals k times 20. Next, we can just divide both sides by 20, and we get that k is 11.5. So then plugging that back into our equation, instead of I equals kt, we now know k is 11.5, so that means I is actually 11.5t. So for part 3, how much will Jason earn if he works 30 hours per week? So that's the question we want to answer. We know that 30 hours per week should be our time, so let's plug that into time into our equation I equals 11.5t. So our equation is going to be I equals 11.5t, plug that in, and we get I equals 11.5 times 30, which would be equal to 345. We actually want to answer the question because it's a word problem. We know that I is 345. We want to find income. We see that income is measured in dollars based on the second part. So therefore, Jason earns $345 when he works 30 hours in a week. Let's look at another example. This one's a little bit trickier. A skydiver jumps from a plane. Like any object that falls toward Earth, the distance the skydiver falls varies directly to the square of the time. So if a skydiver falls 64 feet in the first 2 seconds of the jump, how far will he have fallen after 2.5 seconds? There is some extra information here because they're describing a physical property, but the first sentence we care about is that distance varies directly with the square of time. So distance varies directly as time, or square of time, I should say. So this would be time square, t to the second power, essentially. Okay, so I'm going to use d for distance and t for time, and we get distance would equal k times t squared, because that's what it says. The distance varies directly or with square of time. So for step 2, we just want to plug in our numbers. That's our second sentence. If a skydiver falls 64 feet in the first 2 seconds, so we have 64 for distance and 2 for time. So we have 64 equals k times 2 squared. Well, 2 squared is just 4. So we have 64 equals 4k. Divide both sides by 4, and we get that k is 16. So plugging that 16 back in for k, we get distance equals 16 times t squared. For step 3, we want to answer the question. It says here, then how far will he have fallen after 2.5 seconds? So 2.5 seconds is a time, so let's plug that in for time. So distance equals 16 times 2.5 squared. And I just used a calculator at this point, and I got that distance was 100. Okay, so we know distance is 100. We know that in the second part, distance was measured in feet. Therefore, this would be 100 feet. So the skydiver would have fallen 100 feet in 2.5 seconds. The next type of variation we'll explore is inverse variation. With an inverse variation, the problem is going to be phrased as y varies inversely as x, or y is inversely proportional to x. So if you see any of these key words, basically the idea of an inverse in here, we know that it's going to be an inverse variation question. And if it's an inverse variation question, the equation is going to look very similar, but instead of y equals kx, as it was for direct variation, it's going to be y equals k divided by x. So the inverse means that k goes in the denominator. Not k, sorry, x goes in the denominator. All right, so let's explore an inverse variation question. Example 3. The volume of a gas is inversely proportional to the pressure of the gas in a container. If a pressure of 48 pounds per square inch corresponds to a volume of 50 cubic feet, what pressure is needed to produce a volume of 150 cubic feet? So first sentence is setting up our original equation. It says volume, I'll use V for volume, is inversely proportional, so that tells me that it's an inverse variation question, to the pressure of the gas. So I'll use P for pressure. So then we have that V equals K over P. And I'm setting it up like this because I know it's inverse variation. So next, we want to plug a volume, second sentence, of 50 cubic feet, and we know it corresponds to a pressure of 48 pounds. So plug in 48 for P and 50 for V. And we get 50 equals K divided by 48. Next, we just want to multiply both sides by 48 to solve for K. And so we get the 48s will cancel, and we get that K is equal to whatever 50 times 48 is, and that would be 2400. So plugging that back in, instead of V equaling K over P, we get V equals 2400 over P. We can now use this for part 3. For part 3, we just want to plug in 150 cubic feet, which would be our volume, and solve for pressure. So we know 150 is our volume, 2400 is K, we just need to solve for P. So let's just multiply both sides by P to get it out of the denominator. And we can cancel out the p's. And so we'll get 150p equals 2400. Now divide both sides by 150. And again, using a calculator, I get that p is 16. This is what the question asked for. It asked for the pressure. Let's put it in the same units that pressure was originally measured in, which was pounds per square inch. So that means that 16 pounds per square inch of pressure is needed to produce a volume of 150 cubic feet. So another type of variation is joint variation. Joint variation really is direct variation, but you might have more than two variables in it. So for example, a problem might say something like y varies jointly as x and z. In that case, the equation would just become y equals k times x times z. And it can be more sophisticated, like maybe you might have something like y varies directly as x and z and r and t and v, and you just keep multiplying. It's actually very straightforward. So let's explore a question with joint variation. So for example 4, it says r varies jointly as q, j, and z. If r is 1260 when q is 7, j is 3, and z is 6, what is r when q is 4, j is 1/2, and z is 15? So we see that it says varies jointly, so that means it's a joint variation question, which again really is just direct variation, just with more than two variables. So we get that r equals k, because that's our constant, times, and we just multiply all the other variables, q, j, and z. For the second part, we want to plug in our numbers. So we know r is 1260, q is 7, j is 3, and z is 6. Let's multiply all those numbers, and we get 1260 equals 126 times k. Divide both sides by 126, and k is clearly 10. Plugging that back into our original equation, we get that r is equal to 10 times q times j times z. Now we can use this to answer the last part of the question, which is what is r when q is 4, j is 1/2, and z is 15? So we want to solve for r and just plug in those numbers for the other variables. So we get r is equal to 10 times 4 times 1/2 times 15. So just multiplying those numbers, you'll get that r is 300. Since this wasn't a very applied word problem, like there wasn't actually units of measurement or really any context to it, it's okay to write our answer just like this. The last type of variation is called combined variation. Combined variation means that we have some parts that are varying directly, and some that are not are varying inversely. Anything that varies directly, you're still going to have your k in there, but anything that varies directly is going to be in the numerator, and anything that varies inversely will be in the denominator. So for example, example 5. Y varies directly with x and the square of z, and it also varies inversely with q. If y is 180 when x is 10, z is 3, and q is 4, what is the combined variation equation? This one's a little bit different than the other problems we were asked for because we weren't actually asked to solve for a specific variable in the end. We were just asked to find the equation. So we only need to go through step 2 in this case. So it says that y varies directly with x and the square of z and inversely with q. So we have y equals k times x times z squared because those vary directly, and we have to divide it by q because that varied inversely. Next, we just want to plug in our numbers for part 2 and ultimately solve for k. So we get 180 for y, 10 for x, 3 for z, but remember we do have to square it because it says the square of z, and 4 for q. So just do the math here, simplify this, and we get 180 equals 90 because 3 squared is 9 times 10 is 90 times k over 4. Multiplying both sides by 4, we get that 720 equals 90 times k. Next, dividing both sides by 90, we'll get that k is 8. Let's plug that back into our original equation, and we get that y is equal to 8, because we know that's k, times x times z squared divided by q.